Hello class, Dr. Mike here for CIS-2640 Network Security / my Security Plus class. This is topic 9, usually week 9. Again, please make sure you always check with your shell and syllabus for the latest any changes in both assignments and, of course, week numbers and so on. But this normally is chapter 9. This is client application security. Usually topic 9, typically week 9 in a 16-week course. So again, this is chapter 9 in the book. It's actually a really good chapter. It's got some good things to talk about. I'll just cherry pick through and show you some resources too you can use to help you with this type of stuff. So again, client and application security. Two big things. Client. Really talk about hardware client. You typically, I'm going to refer to server security more, but you could also use some of these same aspects for workstation, even mobile device, but I'm not going to get into mobile device security too much here. We're really going to focus more on servers. So securing it, a lot of ways though. I mean, physical, the operating system, and the actual hardware itself, hardware protection. So you can start off literally at the beginning here and have a chain of trust, which is called secure booting. And you can use things in your UEFI to actually have a certified OS that can only be booted. Probably the biggest thing, of course, is also encryption of any sensitive data or sensitive partitions. So this hardware ring of trust is really big. Also, if you happen to be a Linux server, you can also put a password on the bootloader. I definitely suggest that so no one can't slip in and do a quick, any kind of physical attack where they can slip in, do a low-level run level 1 boot, put in a new account, and then reboot back into regular run level. So yeah, and if you get any deeper than this, if you get into supply chain security, where you want to know who your source parts were. So there's no funny business per se for nation state attacks. That's even going further, but that's a possibility. So again, secure booting, chapter talks about that. I just mentioned it. BIOS, you can lock the BIOS down, BIOS being the older basic input output. And I believe you can remove booting from external devices and then lock it down. Only boot from this one hard drive and then lock down the BIOS with a password. BIOS passwords can be hacked pretty easily. And this is really more for the mobile device. So if I'm given a laptop and it's locked down by IT, I can literally go and find the steps online to unlock just by putting in the BIOS number, and there's usually a couple different steps to unlock it, because there's always needs to be a way to unlock it in case the password's forgotten. So, but UEFI, you can do that. UEFI, you can also add that chain of trust talked about, and the hardware root of trust. So make sure things are security checks are rooted in hardware checks. So that's a pretty big thing. Let's go to the operating system configuration. So operating system security, pretty straightforward stuff. First off, disable any unneeded services and ports. Example of this is I'm running a Linux server and it has a print server and cups the print server, and I don't do print serving. Why run it? So an audit of your system configuration is definitely needed, and you'll want to create what's called a baseline. And this is real common to have a baseline, and you'll image that baseline and you'll audit that baseline. The idea being you don't have to install from scratch and then go through the checklist each time. So it makes it easier to provision new servers. But also you want to have that checklist, but you can also want to audit that checklist and make sure everything's changed. So again here, disable unnecessary ports. Don't use default accounts. Use strong passwords. Again, use least functionality as much as possible. And you can application whitelist, blacklist if you wanted to. That's your call, which means only allow certain apps to run. or disallow certain apps to run. So again, you want to automate this as much as possible. Biggest one again is to create an image. And this happens a lot with cloud systems. You'll create an image, and again, an image can be audited, and then you can always compare the image to the image baseline to current threats. So security templates in Windows, way to do this too. So there's ways to do this. So beyond having that baseline image that doesn't have ports open, services running, it's got good protections on passwords, things like that. And I'm going to add a note here about services. Again, not just running services that are not needed, but they're running, they're configured correctly. Hence, if I can sandbox something, I'll sandbox it, chown root, things like that, as well as patch them. So patching is definitely a needed thing. And talk about patching not just our operating system and not just our service, but also middleware. You got to make sure you patch middleware. Middleware is like Struts framework, for example, and this is bleeding over into the application security. So we'll come back to that in a second. But patching should go across the board, not just the operating system. Of course, feature updates. You want to have a patching process in place. You don't want to patch just willy-nilly. You want to make sure the patch doesn't break anything too. So a lot of times you'll have your own patching server, you'll have a test server, and so a lot of times you'll see this, you'll have production servers out here. Maybe these are web servers. Maybe they're Linux. These are Linux web servers. And we have our own patching with apt-get or with Red Hat's RPM. You can up-to-date system. You can have your own internal server. And Microsoft has this too. I think it's your own internal update server. So Microsoft has something very similar. The idea is this thing will get updates from, let's say Red Hat. I can run them here. I can see what's new, and I can patch a test server, and I can test it out. If it looks good, I can push that patch out to them. You don't want things to break, so you want to be able to patch that. So that's you want that sort of system in place. Service pack, same thing. Usually they're major deals. You want to test those out. And you got patch distribution, talked about it already. Automation is good, but you got to make sure it's vetted as well as automated. So again, patch reception, talk about that. Move on from that. So, okay, so we talk about services. So network protection, of course. Your ports, only needed ports are open. The services behind them are patched and configured correctly. And on them is the operating system, which is running hardened, uses the term, which can mean it has got administrator credentials are locked out, as well as things you can do. For example, configure your service. For example, SSH service, secure shell. Maybe we only allow access to secure shell from an internal IP address. And on top of that, we don't allow root access on secure shell, no root. This is very common. Again, I have a Linux background. So not only do we gate the IP addresses range for maybe a set of servers, but root cannot log in. That means you have to have a non-root account log in, and then they have to either sudo or become root after they log in. So these layer protections with our services extend to the network. I mean, not just the port, but the network itself, and also internal and how they're configured internally. So now beyond that, we have some called our anti-malware. Usually referred to as endpoint protection. And you might think, a Linux server, do you need anti-spyware, anti-malware? Well, here's the thing. Imagine this Linux server here is also a file server. And it is a file server, maybe running Samba, for Windows clients. We want to make sure we're not hosting something here. So if you have a network share and it's Linux, you may want to have something in place to scan that and to make sure there's no bad files out there. But endpoint protection is big, especially on clients, and this is usually where it starts. So we'll talk about desktop PCs here. This is a hardening on that end, the antivirus, anti-spam. because user unknown beknownst clicks on a link and it gets infected, and you don't want that malware, in this case ransomware, to spread, so it can't lock that out. Maybe it locks down, closes network access, and then it isolates that and as much as possible, things like that. So endpoint protection is a big deal. Again, trusted OS, trusted hardening, least privileges, reduced capacities, kernel pruning. Okay, read-only file system, this is a big one. Read-only file system here. Yeah, it makes sense. It just sort of makes sense in a way. If I have read-only documents, I can mount that as read-only. That's going to help. Now, again, it's still readable, so if there's sensitive documents, doesn't mean I should not watch those, but that's also an option. Kernel pruning. This is something on Linux side specifically. It's iffy. If you modify your kernel and let's say you use Red Hat, you could run into actual issues. But it is possible to review your kernel and look at it to remove certain aspects that might cause security issues. So peripheral devices, what's hooked up to these devices, are you going to allow USB to be active at all? Things like that. So you want to secure those devices too. But also not just what can be hooked up to these, what they run. Digital cameras, for example, multifunctional displays. Maybe it's our front office here, and we have a welcome podium, but then maybe it has like a touchscreen display with a list of all the offices and who's inside of them. How's that hooked up? Is there a Wi-Fi out there too? How's this thing hooked up? Is there a USB port on that's open that maybe can be overridden on the OS and get someone a foothold in? So endpoint hardening too goes beyond just the desktop, the laptop, the mobile device, and of course the server. You got to think about these external devices also. So again, external sort of devices, cloud-based devices. Now, again, cloud computing is here, it's everywhere. Cloud, you might have a mix of both cloud and internal. Usually you should make sure the connection between them is secure. But also cloud security in general. Don't assume because you have cloud, it's secure. You could probably Google as many articles saying an unsecured S3 bucket on Amazon led to leaking of this data. There are people who scan for S3 buckets and look for stuff. I'd say also external storage. Look at GitHub. Places where users might use GitHub or some sort of repository service. Make sure that's not public. You don't want your source code leaking out. Again, cloud storage, talk about it there. And physical security. Who has access to these things? Who's got the keys? How do they gain access? So I worked at a place with a data center, and we had to show up to the data center building, give them our badge. Of course, we use our badge to get into the outer lobby. And then we'd give them our badge, and they would see our badge, verify who we are, and they would take our badge and give us a temporary badge that was, I think, a 24-hour only key on it that would let us into the data center. And then inside, someone would let it unlock our cage with our servers. So, very layered access. And you'll see there's things called man traps here. Barriers, guides, motion detectors. Physical security should be part of your security awareness when it comes to servers, data center, things like that. Door locks, things like that. Protection of your cabling. You want to run a cable around and out, external of the data center door. It is, what was temporary once becomes permanent, in my experience. And that cable is running sensitive data back and forth. Maybe it's a backup server. So yeah, it's not external to the world, but that cable is pushing sensitive data on it, and it's just sitting in the open. And just a quick note here too is when it comes to the security of your cabling, also security as in personal security. I worked for a company out of Cincinnati once for a little bit and went on to a site visit, and the install engineer walked around the client's data center and tripped over a cable that was strung across the floor. That was like a few inches above the floor. It was supposed to be temporary, and he tripped and fell into a cabling rack and almost tore his eye out. So, yeah. So security too, think of personal security too, right? Access lists, definitely want this. Again, when someone comes in, you want to know who came in when they checked out, who let them in. And you want to have this record backed up. You want to have it auditable. You want to be able to audit who came in and left. This is forensics data if something ever happens. So man traps are a big way to do this. Maybe you buzz someone in and there's someone inside to verify that. Like another story, I worked at Intel Corporation, and it used to be we walked up, we just showed our badge. I said, oh, and some guards said, okay, come, hey, you go on in. And it happened to be that someone lost their badge. You lose your badge, you put it in, they give you another one. I think you pay like $5, I don't know. And of course, if you find your other badge, you have 2 badges. And there's no RFID scan of the badges. And what happened was someone who worked at IT did that. They sort of said, they worked the support desk. They said, well, I lost my badge, I got another badge. When they were let go, they were fired. And I think they knew they were going to get fired. They returned the badge they said that they were given. Well, they kept the old one. And still walking around, they were able to walk in and say, oh, I work in IT. They knew the process. They were now a fired employee who could just walk in, wave their badge, oh, go on in. And they stole a bunch of memory out of desktop PCs and tried to sell it on eBay. They were caught, but but in case. After that, they put into place RFID, beep. So if you were a fired employee, now that employee badges now would buzz an alarm. So, all right. So second part here. So again, server security, very important. There's a lot of aspects to it. And I'm going to say too is here's something to help you out. So again, you don't have to come off of this brand new. There's a lot of resources you can use for server security. One of these here is of course NIST. The NIST 800 series, SP 800, is fantastic special publication series. And this is a doc here, and it's free. And I can take this and run through it. Security planning, okay, patch upgrade systems. I can use this as a checklist to go through and ask questions. I can build here, walk through this document and look for, do I have disabled and inactive accounts? Do I have user groups created? I guess it is not really a checklist, but I could create a checklist from this, one that applies to my systems. And then I can keep that and use it each time I do an audit. Password policies, do we have one in place? What's the length? What's the complexity? Is there agent in you? So on. So this is a fantastic resource. I'm not going to go through all of it here. But yeah, look for NIST. This is the SP800-123. The whole special publication 800 series has a bunch of different security. There's probably ones real specific to different operating systems. This is a general guide to security, though. It's a great place to start. And part of this, of course, is securing the server software. So we're going to talk about this in a little bit here. So this leads us into our next topic, which is application security, but also application security when it comes to, here we go, application as in apps, as in code. All right. So the second part of this, I sort of talked about when I talked about struts framework. Should be part of your patching process. Any type of frameworks, JavaScript frameworks, struts frameworks, those things that are on those servers that are exposed to the outside world should be evaluated and patched. And Equifax should be the first thing to come to mind. Equifax had a struts framework that was out of patched, and they were known about it, and it was exploited. And of course, I don't have to go any more into what Equifax hack was. If you're taking my class, that should be pretty apparent. So, but as you make applications themselves, there are things that if you don't build in secure coding techniques, that's the key right there. Secure coding techniques or secure coding application development processes, you're going to end up with things you see on this OWASP top 10 list. Again, OWASP talked about this previous chapters. It's a fantastic resource and probably still number one. The injection vulnerability. So, and this comes down to the fact it's cheaper to build this in design than it is to go back, find it in a pen test, which you paid money for, either internal money, time, and effort, or maybe you hire a company, and find that there's a SQL injection on a web page, and had to go back, patch it, and find a way to fix it. And of course, it's even worse the fact you could be breached by the ones you did not find. Um, so this whole top 10 list here, again, OWASP is a great resource. Injection, authentication, this could work between both configuration of your server, but also software. So injection and broken authentication, access controls, again, not set up correctly, server misconfiguration. This is the cornerstone of my doctorate dissertation, in fact, so with Linux security. Misconfiguration, and we see this more and more, even with cloud. I mentioned before, S3 bucket, the Amazon bucket was misconfigured, and data was out there exposed to the rest of the world. And the last one here is insufficient login or monitoring. This is a good one. This goes into your server design. This is not really secure coding. It's sort of secure configuration, but it's something you got to think about. Logging is going to be, your logs are going to be your breadcrumbs. It's your forensic data when something goes wrong. It doesn't mean forensics in the term of, we were hacked. It could be, we deployed something in our servers and now nothing's working. What happened? What broke what? These things can be used to help troubleshoot all kinds of issues. And just a quick note here, remote logging is very, very important. Those frontline servers you have running, your web servers, and maybe you have a couple application servers and your database server. Again, this is sort of generic architecture here. A database with our apps, servers which are load balanced. We have a load balancer here for web servers. All these will write logs locally. Keep in mind, if this is in the cloud, these might be ephemeral, which means that this instance is removed. Maybe we think we got hacked. Well, get rid of the instance. Just get rid of it. We'll fire up a new one. Those logs are gone. So logs are generated on all levels here. And it's very common to have something called a logging server, which has a copy of the logs written to. And the idea is if someone does intrude and they remove themselves from the logs, that is not removed here. And also, this gives you a place to do log processing. So we can run Splunk or some commercial application to create those dashboards showing current issues, things like that. So, and not just servers, but network devices and so on. So logging and monitoring, make sure it's sufficient. So again, it's coming back to the security part. But when it comes to coding and testing, make sure your code is cutting the correct error messages to the correct logs. So we talk about application development. Normally there's something called the waterfall approach. And it depends, everyone's different. Waterfall being we design the app here, and we code it, and then we test it, and then we maintain it and deploy it, right? And it's a waterfall because it goes in stages like this. So we develop it, we write the code, we test it. Now, in real life, it's not that simple. It really is cyclical, comes back. Even though the app's been out for a while, maybe it's a web app or mobile app, it has to go back and it gets redeveloped. It gets code. Even coding goes back. They go back and redevelop sometimes code was incorrectly. Testing will have coders go back to fix bugs and so on. So you get this sort of cyclical life of an application. This is usually called waterfall, which you see here. Agile is just a way to break this into smaller chunks. Instead of just developing the entire app, and with web technology these days, HTML5 and so on, you can do Agile a lot quicker. Facebook is a good example. They do very Agile. They almost release every single day with their PHP backend. So I don't develop the entire app from front to back, then code the entire app, then test the entire app, and then put it out to production. I break it into smaller chunks. And I might deploy just the initial part. I need to get the thing running, and then we're going to deploy some new features here. And so it's done very small, very agile. And I'm looking into the full agile methodology, Kanban, and things like that. You can definitely look that up. And if you are a software developer, you'll probably learn about that. But understanding the life cycle is important even as a security professional, because you might be able to find ways to help a development team get bug fixes in. And a bug fix for security, you just said it's a bug fix. And so understanding how they work is going to help you deploy fixes for found issues. And this is called secure DevOps. This methodology, which means continuous integration, security, automating security, automated scanning, things like that. The baseline we talked about, baseline your servers, looking for any changes. And on that, there are ways to help you with this. And one is this here. You might use a tool like Nessus that will automatically scan a set of servers looking for vulnerabilities and maybe certain types of scans. And then you can also automate these things. You can do scheduled scans and then alert. So there's tools to help you do these scans. Get back over here. So provisioning, I talked about before too. This is a big thing. If you provision, make sure you're provisioning the proper baseline. Hence, you make it a copy of the correct server with all the correct configuration, as well as the code too. Code, where it's held at, the repository. If it's in GitHub. Also, when the code is put together, it goes through and gets tested. So code testing is a big deal. It can be problematic though. I say code testing. That means developers write a web page or an application stack, maybe with Java, that's going to handle maybe an order processing. When you compile it, you can use static compiling tools that will look for those things we saw in OWASP there, which I closed, but such as injection vulnerabilities, things like that. Proper error handling, proper input validation. There's ways to test for that, and you want to find it during development. Static code analysis can be very noisy, a lot of false positives. There's something called dynamic code analysis, where you actually put an agent in the test area. And the agent will do these tests while it's being ran, as well as some static analysis too. So this costs money, but it definitely is worth it if you don't look for things like proper input validation. This leads to, of course, cross-site scripting and SQL injection, things like that. You want to find those during coding, and especially during compiling. Memory management, for example, things like that. Now, a lot of this is going to be really quality of code. I have talked about already. Compile runtime. So, talked about that. Move on here. And that's what the analyzers do. There's fuzzing, stress testing. Stress testing definitely something you should be doing on code. Not just code. That's the complete stack. That means the code, the middleware, the servers can handle the stress testing, the integrity measurements. Do we know what we're running is correct? And I think we looked at code signing for one. It's a good way to confirm things like that. And fuzzing is part of dynamic analysis, and some code testers will do this, like the Nessus I showed you, OWASP Zap, Burp Suite. These sort of tools you can use to run internally, sort of run your own internal code scan, your internal app scan, I should say. So code security is a huge deal. There's a lot to it. I think I briefly touched upon it, probably just enough. Look at the chapter. Make sure I didn't miss anything. In my opinion, that's still one of the biggest weaknesses with security. We see network security used, that network security, server security is a big deal, but that code security seems to be an issue, and that's why, if you look at the OWASP top 10, I bet you injection is still up number 1. Misconfiguration number 2, broken authentication, just the way our code is written. So, and it goes to a point here where, because people learn the code, and then later they learn security, but they're so busy just getting the code written and tested and out the door because they're on a schedule, they'll get a security professional come in and do it for them. So that's where that DevSecOps comes in. The idea is security needs to be baked in to the entire development cycle, from when an application is first scratched out architecture development to when it is deployed and supported. So that wraps up the chapter here. I think I talked about this already. Yep, NIST, good stuff on NIST there. Wraps up chapter 9 on client application security. Thank you.